A very good morning to Dr. Nor SURAYAHANI. I'm KHANG. We are from Group 3, Section 2. Below are my fellow group members Yuan, and CHUN. So today we are going to present about the assignments of Engineering Statistics BE 32502. So I'm going to present about the introductions. Introduction is divided into two parts. The first part is about the brief information about linear regressions. So by using linear regressions, we can obtain a linear relationship between a dependent variable and an independent variable. Hence, we can make predictions about the future outcome with the aid of linear regressions. The independent variable will be not affected by the other variables, while the dependent variable will be affected by other variables. Therefore, a mathematical relationship between variables can be stimulated by using linear regressions, which hence as well as predicting the future outcome. Normally, x-axis will become the independent variable, while y-axis will become the dependent variable. Fit line can be drawn also in the graph, which is also known as line of regressions. By using line of regressions, we can easily interpret the data retrieved and work out the solutions or come to a conclusions. So I'm going to move to the next part of introductions, brief information about the report. So the aim of this report is to find the relationship between diameter and the breaking strength of conductor use. By using the linear of regressions, we can predict the diameter and breaking strengths of aluminium. Besides, graphs are made to ease the visualizations and interpretations of the data, such as graph of residue against predicted dependent value and graph of residue against breaking strengths. That's all from me, thank you, and I'll pass to other group members to present about the data requirements.
A very good morning to Doctor. My name is Jachi. Next, I will continue to the part of data requirements. This data is collected from the website and is related to diameter and the breaking strength. So we use this data to calculate the mean, variance, Pearson correlation, and determination coefficient. Next, the diameter is manipulated, so it's the independent variable, while the breaking strength is measured, so it's the dependent variable. Next is related the software. We choose Microsoft Excel as the software to solve our project question. Microsoft Excel can be used in accounting, charting, graphing, and etc. Not only for that, Microsoft Excel also can store much data just in a sheet, such as our project. We use 31 data for breaking strength and 31 data for diameter. Next, Microsoft Excel also can perform calculations, such as in our project, we need use Microsoft Excel to solve the mean, variance, coefficient, and Pearson correlation. Furthermore, Microsoft also can analyze different types of charts. So in our project, we use the chart is a scatter chart to plot our graph. And then lastly, Microsoft Excel is a powerful tool for analyzing and visualizing data.
A very good morning to Dr. Nor SURAYAHANI. I am Jachi, come from Section 2, Group 3. Now I will show how to use the Microsoft Excel to solve our project. So this diameter and breaking strength data are come from the internet. First, I will show the sum is equals to sum. So for the diameter, we just find out it. So this is the value of sum, and then we use this plus to pull to the left to get the value of for the sum. And this is equals to x. For diameter, so it's done already. So we pull again. And this is the value of mean for breaking strength. Next, for the values, S is represented for the sample. And next, the Pearson correlation is supposed to be called everyone is represented for the X value, and then comma for array2 is represented for Y breaking strength. So the determination coefficient is equal to R Q. Okay, Y is our breaking strength, comma for our X is diameter value. So you get your determination coefficient value. Next, before we find the theta value, we need to plot the scatter plot first. So we highlight all the value for diameter and breaking strength. Go to insert and search for this one, scatter. So this one is our scatter. So we find the axis. This one is our diameter. This one y-axis is for our breaking strength. So the scatter plot data is done already. We will plot the simple linear regression graph, but before that we need to plot one more scatter graph. So insert, choose the scatter graph. And then in this weight layer, we choose for this one. This one is for the diameter. This one is for the breaking strength. So we will use the simple linear regression this equation to solve our fitted value. So fitted value is equals to 30211 times 1 diameter, and then minus 7546 for the line. And then just go down until here. So we'll get the value of the fitted value, and then this sum value also calculated because just now we have sub the equation already. So the residual is equals to breaking strength minus fitted value. So also same get the value of the sum. And next we need to plot the residual value against the fitted value. So this one is the next is residual against diameter. So scatter the last one graph is residual against the breaking strength. So it's so scatter it's 0. That's all for me to show the demonstration using the Microsoft Excel. Thank you.
For the result and discussion, based on the assumption made, which are residues and variance are similar, residues are normally distributed, residues are independent each other, and the existence of significant outlier. Model is homostatic, which spread of residue is the same in any vertical direction, and the model has no trend, which randomly spread with no obvious pattern. The residues plot also does not show any existence of significant outlier, which will affect the result of the plot. For the coefficient of determination and Pearson correlation. Coefficient of determination is measuring the variation of the dependent variable, while coefficient of Pearson correlation is measuring the strength and direction of linear relationship between two variables. The outlier is significantly affecting the coefficient of determination. Coefficient of determination of which is R squared from the simulation is 0.9076, which means 90.76% of the breaking strength of aluminium is mainly due to the diameter of aluminium. Coefficient of Pearson correlation, which is R from the simulation, is 0.9526755459.
Good day to lecturer and my fellow friends. My name is Syen and my math record is AE 2062. So I will be presenting the last part of our project, which is the conclusion. And we can state that the regression model can accurately predict the diameter and the breaking strength of the aluminium. From the graph, we can saw that the line is linearly up, and the simple linear regression model of diameter against its breaking strength has a strong and positive correlation to each other, and this is supported by the value of coefficient of Pearson correlation, which is 0.9528, And we can say that a strong linear regression model is between the value of coefficient of Pearson correlation is between 0.1 to 1. So the value we get is 0.9526s, which is very close to 1. Okay. Thank you for watching our video presentation.